Hey guys, so this is lab 3 of physics 2211 black hole. So here are just some key formulas to go over which are going to be important for this lab. Obviously we have the universal gravitational law. It's equal to the g times m times little m over r squared times r hat. Newton's second law, which has been very important in every lab. Instead of F equals ma, we can also just write it as the parallel force plus the perpendicular force, and then here we have the parallel force, and here we have the perpendicular force. Okay, so what is the objective of this lab? The objective of this lab is to first of all find the mass of the black hole with a computer simulation and calculate the initial velocity of a spaceship so it can escape the black hole, and we'll be using some guess and check for that. Okay, so here are just some initial conditions of our part 1 of the lab, glow script number 1. So we have the mass of the star. Note that 86400 total T is 1 day. And then here's some results. So actually what I'll be doing is I'm just going to walk through the first part of the lab, just go over some of the important points. So sorry about that. So we have our constant, the mass of the star, delta T. And then we can see here delta V equals V final minus V initial, same with delta P. And then we can calculate the change in momentum right here, and we can use Newton's second law to calculate F net, which is just equal to the change in momentum times the change in time. Here we can do it for the parallel component here, and we can do it for the perpendicular component here. And then here, with all that information, we can calculate the mass of the black hole. And then we run the program and we get an actualized value. But anyways, let's go over to the second part of the lab now, glow script part 2. Again, we're going to use, I just want to talk a little bit about, our result was the mass of the black hole is 7.41 e to 33 kilograms, and we're going to be using that value along with the mass of the planet. We're also going to be using the initial velocity of the spaceship in both the x and the y component, and this is going to be really important because we can use some sort of guess and check to find out what escape velocity is needed. Just here, part 2, just run through it. These are the constants that we are given, and right here we have our speed in the x and in the y direction. Of course, some guess and check is needed, and then we can calculate the necessary things. For example, calculate the radius, which is from the black hole to the planet, which is going to be the planet's position minus the black hole's position. We can calculate other things needed like force of black hole on the planet, and here we just use a universal gravitational law. Just like that, we follow a similar structure using parts of the gravitational law, and then if we want to find the net force on the ship, it's going to be the force of the black hole on the ship plus the force of the planet on the ship, because keep in mind that there are two forces in play. Okay, some sources of error. I could have potentially run the program for a longer period of time and use a smaller delta T. Additionally, because I was using some guess and check for the initial velocity needed by the spaceship, I'm not going to get an exact value. So those are some sources of error. Here's some what ifs. So the main what if I had in this lab was to find the initial velocity of the spaceship to safely orbit the black hole, and how would that change the experiment. So probably increasing the y component a little bit, y velocity a little bit, and decreasing the x velocity. But this is just an interesting thing to keep in mind and question. But yeah, this was my overall lab. Discussed the key formulas, the purpose of the lab, and discussed both parts of the lab with the script in hopefully necessary detail, and then talked over some sources of error and some what ifs.